Today's lesson is on parametric equations and arc length. So we're going to focus on finding arc lengths of curves given by parametric equations: speed, velocity, distance, and arc length. So we know that parametric equations can be used to describe the path of an object moving in a plane. This leads to asking the question, how far has the object traveled? A particle moving along a curve in the plane with parametric equations, x equals f of t and y equals g of t, where t is time, has the speed given by, that's what's right here. So I'm going to write something right now. This refers to speed, which shouldn't be new to you. You should be familiar with that. It's one way to write it. Here's another way to write it. We can find the distance traveled by the object moving along the curve between 2 points t equals a and t equals b by integrating its speed, such that the distance traveled is the integral from a to b of v of t dt, assuming the object never stops or reverses its direction as it moves along the curve. The distance traveled is the length of the curve, so arc length. Here's an example. An equation of the form y equals f of x, where x is in between a and b, has an arc length L of such a curve is given by the definite integral below. We're going to use the formula below to find the arc length from x equals 0 to x equals 3 for the function. So this is kind of a review of what we've already done, and I can't remember what unit we dealt with this, but this isn't even dealing with parametric yet. This is just dealing with basically how to find the arc length, refreshing your memory on how to do this. Okay, so the first thing we have to do is find a derivative. So let's do that first. So that is going to be 3 over 2, 4x minus 1. That's going to be 1/2 times the derivative of the inside, chain rule, all over 3. All right, so we're going to have 4 times 3 is 12, divided by 2 is 6. 4x to the 1/2 over 3. So what do we have going on here? We have, all right, 6 divided by 3 is 2. Well, the square root of 4, because 4x to the 1/2, you take the square root of both, that's 2, and x to the 1/2. So the derivative then is 4. That does not look like a 4, so let's fix that. Is going to be 4x to the 1/2. And so now we can use this formula. We're integrating from 0 to 3. And we're going to square. Oops-a-daisy. I'm not doing very good today here. I need to write. There we go. So 4 squared is 16. Square x to the 1/2, that's just x dx. Now, on any of these arc lengths, we're always going to use our calculator, and I'm going to refresh your memory on how to do that, and then from then on, I'm probably just going to give you the answer, and you can do it on your own. So right now, just some refreshing your memory, give me a minute for the calculator to come up. I have to switch my calculator back to function mode because I'm dealing with x's and y's. I'm not dealing with t's. So let me go back to my mode from yesterday, and let's switch it back to function for right now. We're going to go to y equals, and what we're going to plug into y equals is this. 1 plus 16x. And then we're going to go to math 9. Oh boy, oh boy, oh boy. We got to try that again. No. Okay. 1 plus 16x. There we go. Let's get out of here. Now I'm going to do math 9. 0, 2, 3. And once I go into here, I'm going to hit vars, y vars, function, y1, and x, and enter, and voila. 14.25 is our answer. So we will go back here and I'll get my pen back here. We will write 14.25. I'm just double checking. You've used okay. All right. What did we just find? The arc length. If a smooth curve C is given parametrically such that C does not intersect itself on the interval, T is in between A and B, except possibly at the endpoints, then the arc length of C over the interval is. Same thing, arc length, distance traveled, arc length back here. Difference is when you're dealing with just x's and y's, it's 1 plus f prime of x squared. And we did, way back when, showed you how these formulas were derived. Now we're dealing with parametric, so we have to use dx dt squared plus dy dt squared. So basically what we're doing is we're integrating velocity, and that is distance traveled, and that is your arc length. But I'm going to go back and write again. Example 2. Randy the Roach is moving in the xy plane at time t. His position is given by the parametric equations. Gives us dx dt, dy dt. Find the distance Randy traveled from 0 to root 15. So here we go. 0 root 15 dx dt squared plus dy dt squared dt. Okay. We know what dx dt is, it's 3t. And we know what dy dt is, it's t squared. And let's simplify this a little bit. Okay. So that's going to be 9t squared plus t to the 4th dt. And what you're going to do right now is you're going to plug this into your calculator. And I wrote myself a note. I just want to double check something. Parametric mode on calculator, if you use t instead of x to integrate, we'll get the same answer. Okay, so if we use our calculator here, whether we're, honestly, when we integrate, whether we're in parametric mode or whether we're in function mode, we're going to get the same answer. But I'm going to make sure that I'm not making something up right here. Because if I go to y equals and I clear this out and I go like this and I type in 9x squared plus t to the 4th. And let's get out of here and go to math 9. And we're going to go 0 to root 15. And bars, y bars, enter, enter, x, enter. And that is the answer, 30.192. So technically, when you're just integrating, whether you're using t's, dx dt's, or just x's and y's, it honestly doesn't matter what mode you're in when you are integrating. So there's our answer right there. So what do we get? We get 30.192, and that is the distance Randy traveled from t equals 0 to t equals root 15. All right, example 3. Yeah, I probably better do this. Okay, find the length of one arch. One arch represents 0 to 2 pi. So what are we going to do? We're going to integrate from 0 to 2 pi, and we have to do dx dt plus dy dt squared. So let's go dx, well, d theta, we're dealing with not t. Dx d theta is going to be 1 minus cosine theta, and dy d theta is going to be sine theta. So it's 1 minus cosine theta squared plus sine theta squared d theta. We'll simplify this a little bit. Okay, so 1 minus cosine theta squared is going to be 1 minus cosine theta, 1 minus cosine theta, plus sine squared theta d theta. Okay, so what do we get when we multiply those together? When we multiply those together, we are going to get 1 minus 2 cosine theta plus cosine squared theta plus the sine squared theta d theta. Well, here's the deal. I'm going to change my color, second blue. We can see something. That's 1 cosine squared theta plus sine squared theta. So now putting this all together, 1 plus 1 is 2, and 2 minus 2 cosine. If we plug that into our calculator, you're going to get an answer of 8. So 8, that is the length of one arch of the cycloid. All right, now we're looking at a graph. This is a little more tricky. For t greater than or equal to 0, a particle is moving along a curve so that its position at time t is x of t, y of t, where x of t is shown in the graph at the right, below and to the right. For the particle, it gives us this information right here. Find the speed of the particle at t equals 1. Well, we know that speed is going to be the absolute value of velocity, which is going to be dx dt squared plus dy dt squared. We're not integrating. That's finding distance. That's finding arc length. We're just finding the speed, which is this formula right here. All right, so dx dt is x prime of t. And to find this, we're going to use the graph, and we're going to use 2 points. So at 1, t equals 1, it's about right there in the graph. So the 2 points I'm going to use the point 0, 0, and I'm going to use the point 2, 5. And I'm going to go back to the basics of finding our slope, which is 5 minus 0 over 2 minus 0. So 5 over 2, that's x prime of 1. To find y prime of t, that's going to be, when you look up here, that's going to be x prime of t squared times the derivative of the inside, which is 2t. So that means y prime of 1 is x prime of 1 times 2, which is 5 over 2 times 2, which is 5. There we go. Now we're ready. We are now going to find our velocity, our speed, actually, the absolute value. So that's going to be 5 over 2 squared plus 5 squared. And so that's 25 over 4 plus 25. Get a common denominator. You get 125 over 4, which is, and we're assuming you can't use a calculator here. That's why I'm doing all this with radicals. 25 over 2. 125, if it was an MCQ, would simplify to 5 root 5 over 2. And what did we find? We found the speed of the particle at t equals 1. All right, example 5. At time t, the position of the particle moving in the xy plane is given by the parametric equations. It's giving us dx dt, it's giving us y of t, and the function f of t is continuous and differentiable with selected values shown in the table below. Find the distance traveled by the particle. So now we're going to have to integrate speed. First of all, we need dx dt, which we know is 2 f prime of 2t, and we're going to need to know dy dt, which is going to be the derivative of this, which is just going to be square root of 3 times f prime of 2t times the derivative of the inside, so 2 root 3 f prime of 2t. So here we go. Our total distance is going to be, we're going to integrate from 1 to 5, and we're going to integrate speed. So here we go. 2f prime of 2t squared plus 2 root 3 f prime of 2t. That whole thing, I need one more parenthesis there. Squared. Oh boy, I gotta sneak on my dt. Sorry about that. Oh, total distance way too big. Let's move that over. 1 to 5. So that would be 4 f prime of 2t squared plus, that squared is 4 times 3 is 12 f prime of 2t squared dt. And okay, extend the page. Okay, get up there. Extend the page, and get back to my pen here. All right, let's see. What do we have here? Let's keep going. Square 4, that's 16. Wait, I'm not squaring 4. Never mind. I'm not, what am I doing? Never mind, back up. We have f prime of 2t squared, f prime of 2t squared. So I can combine the 4 and the 12 and make that 16 times f prime of 2t squared. Now, the square root of 16 is 4, and the square root of a square, done. Now we're ready to integrate. So when we integrate this, what do we get? We get 4 f of 2t divided by, so think u sub, divided by the derivative of the inside, evaluated from 1 to 5, which is just going to be 2 f of 2t. And here we go. Fundamental theorem of calculus, 2 times 5 is 10. 2 times 1 is 2. And now we go back to our graph. Not our graph, our table. F of 10 right here is 9. F of 2 is 3. 18 minus 6 is 12. What is that? That is the distance traveled by the particle from t equals 1 to t equals 5. Okay, so I'm looking at example 6. We probably should at least start it. I may not finish it. All right, so at time t, the position of the particle moving in the xy plane is given by the parametric equations, where it gives us dx dt right here. The graph of y consisting of 4 line segments is shown below. When t equals 0, the particle is at the point xy. So that means that x of 0 is 4 and y of 0 is 0. That's what that means. All right, so let's go to part A. I might have to rewrite a few things so I don't have to keep flicking back and forth. I'm going to write down what dx dt is, t squared plus sine t squared. Find the slope of the line tangent to the path of the particle at t equals 3. Slope. Okay. Slope is dy dx, which is dy dt over dx dt. So dx dt, we can use that formula, but for dy dt, we're going to look at the graph. And when t is equal to 3, it's on this line segment right here, and I can look very clearly that the slope is going to be down to to the right one, down 2 to the right 1. So based on that information, I know that dy dt when t is equal to 3 is -2. So I'm ready. I got -2 over dx dt. Well, I better do a little side note here. Let's go down here. Let's find dx dt when t is equal to 3. That's going to be 9 plus sine of 9. Okay, 9 plus sine of 9. So we have -2. And that's going to approximately equal, because look at what this says. This is a calculator problem. So we can use our calculator. We're going to get -0.212. 3 digits after the decimal is what we use. Find the speed of the particle. Well, dx dt and dy dt. And plugging that into your calculator, you're going to get approximately 9.622, and that is the speed of the particle at t equals 3. Find the position of the particle at t equals 3. Okay, what are we finding? We're finding this, x of 3. So we have to start with our starting position, and then we have to integrate from 0 to 3 to figure out the distance traveled. So what this represents, this is our distance traveled. So our initial position, if we go all the way back, when t is 0, x is 4. And we're integrating from 0 to 3. We know that x prime of t gave it to us is t squared plus sine of t squared is t squared plus sine of t squared. This whole thing, dt. So what do we get? 4 plus. If we plug this into our calculator, I'm going to carry extra digits. 13.774. That is the position of the particle at t equals 3. So we always have to start with our initial position. So this is our initial position, and we have to add on the distance traveled. And why we're only using x prime of t is because we're finding, I don't think did it ask us to find, I'm looking, particles at, okay, you know what? Find the position of the particle. Yeah, I'm not quite done, am I? Find the position of the particle at t equals 3. I found the position of the x. I have to find the position of the y. So we know that when t is 0, y is at 0. So then at t equals 3, let's draw a little number line here. 0, 1, 2, 3. So then we know that the position, so that means we know that y of 3 is going to be 4, because we know that y of 0 is 0. So then when it's 3, think about your at 1 is 1, 2 is 2, 3 is, wait, what am I doing? I'm going to make sure I didn't mess something up here. Sorry, guys. Y of 3 is 4. Yeah, yep. Okay, so let's write that down. So we know that when t equals 0, we're at 4. When t equals 0, the y value is 0. At 3, it's 13.774. And at 3, for the y value. Oh, no. You know what? What am I doing? I have to use the graph. Oh, never mind me. I'm just... Okay. Just pause for a minute. I apologize. When t is equal to 3, because this is the graph of y of t. So when t is equal to 0, obviously it tells us, but we're right there. So when t is equal to 3, y of 3 is going to be 4. That's where that came from. Ignore my little number line. I apologize. Yeah, ignore the number line. That had nothing to do with it. How we found y of 3, again, I just forgot that we had the graph here. Okay, last but not least. So here, this is all the answer to part C. This is the position of the particle. So at t equals 3, the particle is at 13.774, comma 4. That is the position. This is part C. And the equation of the tangent line, here's the deal on that. We already really know everything because we know the slope is negative 0.212, and we already know the position. So I can do part D very fast to find the equation of the tangent line, and then we will be done with this long video. Y minus 4, because that's the position. We're trying to find the tangent, trying to find the equation of the line tangent to the path of the particle when t is equal to 3. There's the slope. All right, there we go. 1, 2, 3, one more video, not video, AP questions, and I will be printing those. Sorry about that. Why is this not going? I don't know. There we go, right there. I will be printing them.